Hello everyone, welcome to a series of new problems. Now this series will come from 2020 IIT JEE exam, and this is the first paper. So this is 2020 JEE Advanced Physics paper 1, and we have done 2024 24 earlier and on this channel. Now let's do go back and we try to do 2020 onward. Okay, let's see. This is a good problem actually. So you have a ball and the plank has a kind of little hole. The ball kind of fits in there, and the size of the hole is like a 2r diameter, and the radius of the ball is capital R. You can see over here it says stable. The ball is not rolling, but if you keep going further, there will come a point where the ball will be, let's see if I can draw over here. Ball will be like that, and its center would be over here. Just eyeballing it, and the plank will be like this, like so. And at that point, it will start to roll. And the question is, what is that point? What is this critical angle? That's the question. And this will be our critical angle. At that critical angle, one of these answers is correct. Okay. Well, how do we really begin to do this problem? So it has to be somehow there will be a torque that will be not balanced, right? Which will result in this rotation, say about this point. So if the axis was here on this side over here, then if the axis, let's see, think of this back of the page and front of the page, axis like that, and it's going to rotate like that. So if I look at the forces at any point, especially over here, you can see the normal force over here. Even what's the normal force? Let's look at this original one. The normal force will be tangent to normal force on the ball will be tangent to this thing. Right? So means over here, tangent to the normal to the tangent will be pointed to the center. That's the normal one. Go through the center, and over here it will go through that center. So let's call this N1. This calls N2. While position, say this is θ1. At this angle, it will. When it gets to over here, right, the critical point, it normally still be pointed toward the center, and over here it will point towards the center. This will be new normal, N1 prime, N2 prime, and in addition to the normal, you have a gravity. Gravity is pointed straight down, mg, and gravity is, when the gravity points a little further, it will start to roll, right? So if you look at a little bit further, the gravity is this way, and the plank is, if the ball was like this, place the ball in this position, it will immediately start to roll. So gravity normal will be this way. This is not correct figure. Actually, I should draw the figure more properly. Let me pause this and draw the figure more properly, okay? Okay, so now I've drawn the figure normally. So the mg is to the right of this point, and if you press the ball in that angle, it will immediately start to roll. So that angle is what we want. And so that for that angle, going back over there, let's redraw it out. So this, I'm not going to redraw it, just over here is enough. You can see the gravity is, so that's the triangle here, and gravity's point is straight down, and normal n2 is straight up, and n1 is in that direction. This n1 must be 0 because it will have a horizontal component, right? But none of them have horizontal component. And just before this point, it's still stable. So as for the first reconcile, these, so you have n2 balancing mg, and n1 is very close to 0. And if you go just over here, just a little bit more angle, then it will end up in that situation and start to roll. All right, so this is the angle, and so we look at this radius here, and this distance is 2r. So look at that triangle. It's like that. This angle phi, and this is r, and this is 2r. If I draw a 90 degrees on it, so this will be r. So in this triangle, if you look at, this is phi and this is theta, then phi is 90 degrees minus theta. So if this is phi, this is 90 degrees. So this, in this triangle here, in this triangle, this will be theta. So you have theta. So in that triangle, we have r, and this theta. So theta all over there. And so sine this theta that we want, that's the critical theta, is equals to r over r. And looking at the possibilities here, this is the answer. It's a pretty good problem. You have to draw it out, and fortunately for you that they don't go into the question of what are the forces, how much the forces there are. You just have the condition by which it's going to roll. So it can be done pretty fast, maybe within a couple of minutes you can do it. All right, so we will stop here, and then we'll come to another problem in a few minutes. Okay, bye.